Hello everyone, I'd like to welcome you to this video titled Using Ratios and Rates to Solve Problems. And the goal for this video is for you to understand how you can use ratios and rates to make comparisons and also predictions. Now you will need to get out your Go Math book and turn to page 161. Get out your math journal, pencil, and also a calculator will help as well. So let's look at the Explore Activity 1 on page 161. So it says, Anna's recipe for lemonade calls for 2 cups of lemonade concentrate and 3 cups of water. And Bailey's recipe calls for 3 cups of lemonade concentrate and 5 cups of water. So breaking this problem down, we're going to take a look at, first of all, in Anna's recipe, the ratio of concentrate to water is what? So what we see is 2 cups of lemonade concentrate and 3 cups of water. So the ratio, and I want you to write this down with me, is 2 to 3. And now what we're going to do is we're going to use equivalent ratios to complete the table. Okay, so what we have here is the concentrate 2, and if it's 4, that means we're multiplying both terms. It's important to understand that you have to multiply both terms in order to get an equivalent ratio. So 2 times 2 is 4, 3 times 2 would be 6. Now what we see here, we're not taking a look at this and just adding 3 to both. What we need to do is take a look at the original ratio, figure out what happens to get to 3 to 9. Multiply 3 times 3 gives us 9, therefore 2 times 3 gives us 6, and we'll write that down there. We can also see we multiplied 2 times 3 to get this number. Now for the final one, we have 15 here. For the water, think about what happens to 3 in order to get it to 15. You multiply by 5, and therefore you're going to multiply that 2 times 5, and that's going to give us 10. And what we're doing here, we're just gathering all this data in order to answer some of these problems here later on with this problem. Now the next one says in Bailey's recipe, the ratio of concentrate to water we can see is 3 to 5. We can even write it this way. Remember, the terms have to be in order, in the correct order here. So we have the concentrate to water ratio 3 to 5. So concentrate 3, and then we go all the way to 9 cups. So what happened to this term of 3? Multiplied it by 3 gave you 9. Therefore, we need to multiply that 5 by 3, and that's going to give us 15. So the next one, what we need to do is look at that original ratio, 3 to 5. What happened to 3 in order to get it to 12? We multiplied by 4. And so what do we need to do to our 5? We have to multiply by 4, and that's going to give us 20. So we'll just put 5 times 4 right there. So the water, what we have here is 3 to 5. Go all the way up to 25 cups. 5 times 5 gives us 25. Therefore, we have to multiply 3 by 5, and that's going to give us 15. So what do we do to 3? Multiply it by 5. We multiplied the 5 by 5 as well. Remember, in order to get an equivalent ratio, you have to multiply both terms or divide both terms by the same number. So now for letter C, it says find 2 columns, one in each table, in which the amount of water is the same, and circle these 2 columns. So what we can see here, water 15 cups, and then we see the water down here 15 cups, so we can circle both of these. And whenever you're taking a look at ratios, whenever you have the same number for one of the terms there, you can see 15 cups of water, 15 cups of water. Now you can answer some real world problems and make some comparisons. So the question is, whose recipe makes stronger lemonade? What we can see here is that Anna's 10 cups of concentrate per 15 cups of water, and Bailey has 9 cups of concentrate per 15 cups of water. So what we can see here is that Anna's recipe makes stronger lemonade. And you can even copy what I have here for letter D. So Anna's, it contains more concentrate for the same amount of water. So we can see here on that, same amount of water there. And so the concentrate is less diluted. All right, now what we can see here for letter E, compare the ratios. We have 10 to 15 and 9 to 15. So whenever we have the same term here, see which one has the greater term. So 10, you can see is greater than 9. Therefore, 10 to 15 would be the greater ratio. Or even think about it as fractions. Whenever you have the same denominator, you just take a look at the numerator and see whichever one's greater that way. And then we can see the original ratio, 10 to 15. We could see that was connected back to 2 to 3. And then 9 to 15, that was connected back to 3 to 5. And then we can see 2 to 3 would be greater there. Now, taking a look at page 162, it's important to understand that you can also use equivalent ratios to solve real-world problems. Now, our problem here on page 162, it says in the science club, there are 2 sixth graders for every 3 seventh graders. So what we can see here is the ratio is 2 to 3. Now, it says at this year's science fair, there were 7 projects by 6th graders for every 12 projects by 7th graders. So the ratio for this is 7 to 12. Now they're asking, is the ratio of 6th graders to 7th graders in the science club equivalent to the ratio of science fair projects by 6th graders to science fair projects by 7th graders? So basically they're asking, is 2/3 equivalent to 7 to 2? I should say 2 to 3 is equivalent to 7 to 12. Now, the way you do this is you take a look at one of the terms and see if it can go in the other term. That's a way that you can find whether or not this ratio is equivalent or not. So we can see 3 can go into 12. All right, now what do we need to do to 3 in order to get it to 12? We got to multiply by 4. And so since we are multiplying the 3 by 4, we are also multiplying the 2 by 4. Okay, so we multiply 2 times 4, that's going to give us 8. 3 times 4, that's going to give us 12. Now, just because one of the terms is the same for our ratio, it does not mean that they're equivalent. It has to be both numbers here have to be the exact same. Okay, so to answer the question, as far as is the ratio of 6th graders to 7th graders in the science club equivalent to the ratio of science fair projects by 6th graders to projects by 7th graders? We can see that the answer to that is no. And we can also see that the ratio of 8 to 12 would be greater than the ratio of 7 to 12. And you can even be a little bit more specific there for the answer. No, the ratios are not equivalent. So again, just make sure whenever you're finding equivalent or ratios that you do not mix up the fact that just because one of the terms is equal means it's equivalent. It has to be, both terms have to be the same. Now let's look at page 163, and we're going to look at how we can use rates to make predictions. Now, you can see for page 163, there's something that you may have not seen before, okay, over here, and that's what's called a double number line, okay? And you can use a double number line to make predictions. So what we see here on page 163, it says Janet drives from Clarkson to Humboldt in 2 hours. And it says, suppose Janet drives for 10 hours. If she maintains the same driving rate, can she drive more than 600 miles? and you need to justify your answer. So what we see here is we have a double number line shows the number of miles Janet drives in various amounts of time. And what they're saying is explain how Janet's rate for 2 hours is represented on the double number line. So we can look at some of these questions here for letters A and B, and that's going to help us understand this number line a little bit. So it says explain how Janet's rate for 2 hours is represented on the double number line. And what we can see here is that the ratio of the distance to the time each interval along the line is equivalent to Janet's rate of 112 to 2. How do we know that? Let's take a look at it. So we have 112 to 2, multiply 2 times 4, also multiply 112, I'm sorry, multiply 2 times 2, that gives you 4, also multiply 112 times 2, and that gives you 224. Multiply 2 times 3, that gives you 6, multiply 112 times 3, that gives you 336, and so on. All right, so we know that it's equivalent to the rate of 112 miles for every 2 hours. Now it says describe the relationship between Janet's rate for 2 hours and the other rate shown on the double number line. So what we can see is both terms in the original rate are multiplied by the same number to find equivalent rates. So we talked about that already. Now understanding this, what we can do, we can see for letter C now, it's saying for us to complete the number line. All right, and what we see here is we see the hours. We have 10 hours. So what do we do to 2 in order to multiply it by to get it to 10? You got to multiply 2 times 5 to get it to 10. And therefore, if we take 112 and we multiply it by 5, we know that's going to give us 560. So in that blank, write 560. And because we completed this double number line, now we can make a prediction asking us or to answer the question for letter D. It says, at this rate, can Janet drive more than 600 miles in 10 hours? And we can see that no, because we have 10 hours here, 560 miles. At this rate, she will drive 560 miles in 10 hours. So let's take a look at another problem where we can make a prediction using a double number line. It says Tim is a first grader and reads 28 words per minute. And this problem is on page 164 in your Go Math book, so I want you to fill it out with me. Assuming he maintains the same rate, use double number line to find how many words he can read in 5 minutes. So we know the unit rate, 28 words per minute. So if we have 2 minutes, what we're going to do is we're going to multiply the 1 times 2 to get to 2. 28 times 2 gives you 56. 3 minutes means we're going to multiply both terms of our unit rate by 3. That's going to give us 84 words in 3 minutes. 4 minutes, multiply both terms of our unit rate by 4. It's going to give us 96 words in 4 minutes. And then finally, I'm sorry, not 96, it's going to give you 112. And then finally, we can see 5 minutes, multiply both terms times 5, and that's going to give you 140. So when we're trying to find out how many words Tim can read in 5 minutes, we can see that Tim can read 140 words in 5 minutes. So let's take a look at these 3 problems to wrap up the video. It says Gina's art teacher mixes 9 pints of yellow paint with 6 pints of blue paint. So we can see the ratio for this is 9 to 6. And we see that Gina mixes 4 pints of yellow paint with 3 pints of blue paint. Did Gina use the same ratio of yellow paint to blue paint instructed by her teacher? So thinking about, are these 2 ratios equivalent? Okay, so what we can do in order to get 3 to 6, what we can do is we can multiply 3 times 2, and that means we're going to have to multiply the 4 times 2 as well, and that's going to give us 8 to 6 for the ratio. So is the ratio equivalent? And we can see that no, it is not equivalent. And writing this out on page 165, you could write, no, Gina did not use the same ratio as her teacher. 9 to 6 is not equivalent to 4 to 3. All right, let's take a look at the next one. It says a Cerez family paid $15.75 for 3 movie tickets. How much did they pay for 12 tickets? And this is how you would set this problem up. You would write the ratio, $15.75 to 3. And then what we're doing is we're just multiplying the number of tickets by 4. Why by 4? Because 3 times 4 gives us 12. And therefore, we have to multiply the price by 4 as well. And then you can see the price for 4 tickets is going to be $63. I'm sorry, the price for 12 tickets would be $63. So $63 would be the price there. All right, let's take a look at this last problem. It says a grocery store sells snacks by weight. A 6-pound bag of mixed nuts costs $3.60. Predict the cost of a 2-ounce bag. So we have the ratio of $3.60 for 6 ounces, and then we have a missing number right up here, but we know that it is 2 ounces. So what happens to 6 in order to get it to 2? We got to divide by 3. And therefore, since we divide one term by 3, we have to divide the other term by 3 in order to get an equivalent ratio. So $3.60 divided by 3 is going to give us $1.20. Okay, so that's how much it costs for a 2-ounce bag. So this concludes the video on using ratios and rates to solve problems. If you have any questions about this concept, please come and see me.